We'll start with the triangles. In this chapter, triangles, we have the similar triangles. Okay, in this chapter, we have the similar triangles. So here we'll study what are the conditions for similar triangles, what are the criterions for the similar triangles, and the PPT theorem is there. So all these we try to study in the triangles. Okay. So first thing, similar figures. If you tell any similar figures, what do you mean by that? Similar figures. Similar figures means the shape of the two figures will be the same. The size can vary. The size can vary. So for example, you have two squares. It has the same shape, right? So they are similar figures. Okay, but their size is different. All squares will be similar, correct? All squares will be similar. Correct. Then circles also, all circles will be similar only. Okay, only their size will vary there. But in triangles, it is not always there. So we will study about the similar triangles. Similar triangles means the shape will be the same. The shape will be the same, but their size can vary. That is what they used to do in paintbrush and all. No, that one triangle used to enlarge that, used to reduce that size and all. There, the shape used to be the same, but it will either enlarge or reduce. We used to do that, no? Those two were the similar. That is, the shape is the same, but the size can vary. Those triangles we call it as similar triangles. Okay. So we will study about that. Write down this first. Two polygons of the same number of sides are similar. They are similar. First thing, if their corresponding angles are equal. Their corresponding sides are in the same ratio, that is proportional. That means they are proportional. Okay. So then we call it as similar triangles or similar figures. Any polygon also you can take, but they should have the same number of sides and their corresponding angles should be equal and their corresponding sides are in same ratio. Then we call it as similar. Okay. So one example, write down this example. Write this. Yeah, it's a quadrilateral. Any figure can be, any two polygons can be similar also. Now here we are writing about quadrilateral. Next, we'll particularly triangles we will study. This is 105, 100, 70, 85. Okay. So this is 3 centimeter. This is 5 centimeter. This one 4.8 centimeter. And here it is 4.2 centimeter. Okay. So now ABCD and PQRS are similar. Okay, they are similar. Now we will see how they are similar. See, angle A and angle P are equal. Corresponding angles are equal. First thing what we told, A and P both are equal. That is equal to 105 degree. So B is equal to Q. That is equal to 100 degree. Then C. Angle C is equal to angle R. That is 70 degree. And angle D is equal to angle S. So that is equal to 85 degrees. So first we observe that corresponding angles are equal. So first condition it is satisfied. Okay, next, their corresponding sides are in the same ratio. What are the corresponding sides? AB and PQ. If I take PQ by AB, how much I will get? 3 by 1.5 I will get. Okay, so that is 2. Correct? Then we have QR. QR by BC, that is 5 by 2.5, that is equal to 2. Then RS by CD, that is 4.8 by 2.4, that is equal to 2. Then we have PS by AD. PS by AD, that is also equal to 2. So, if you observe all the corresponding sides ratio, all are equal to 2 only. Then we call it as similar. Don't take AB by PS. Corresponding sides, that only you should take. So, AB by PQ is equal to, or we have written first PQ, no? We'll write like that. PQ by AB is equal to QR by BC. That is equal to RS by CD. And that is also equal to PS by AD. That is equal to 2. So, corresponding sides ratios are equal. So, the two conditions are also satisfied. That means these two quadrilaterals are similar. Okay. So, similar, what is the condition here? Corresponding angles should be equal. And then the corresponding sides ratios, all the sides ratios should be equal. Then we say that the two triangles are similar. Clear, right? This one. Once you understand basic things, all these, then problems will become very easy to do. See that and tell me whether they are equal or not. The similar or not. Okay. These two diagrams, tell me whether they are similar or not. They are similar because all the angles are equal. So I can write angle A is equal to P, B is equal to Q, R is equal to C, and S is equal to D. Or D is equal to yes, whatever we write. So they all these angles are equal. And if you observe AB by PQ is 3 by 1.5, that is 2. Then BC by QR is also equal to 2. Then CD by SR is equal to 2. And AD by PS is equal to 2. So the corresponding sides ratios are equal here. So the two diagrams or figures are similar. Clear? Similar how it will happen? Clear? Equal only, all 90 only. B and S are equal, no? Yeah. C and D. Huh?
I mean, not for the angle.
What do you angle? That you know. Okay. AB by PQ is equal to BC by QR. Okay, is equal to CD by SR is equal to AD by PS. So that is equal to 2. That means what are the conditions are therefore ABCD, okay, it is similar to PQRS. Then exercise 6.1. First question. Open your textbooks. Exercise 6.1, page number 78. Netra, first question, what is Ash? Listen now, everyone. First question, what is the answer? All circles are similar. Why can't be they congruent?
Because they are
It's different, or the radius, you can say they can have different radius. So all circles are similar. First one. Second one, all squares are similar. Write down. Third one, Sudeksha. Right now. All triangles are similar. Which one? Isosceles or equilateral? Equilateral triangles. Third one, equilateral triangles. Mohita, fourth one. What is the answer? Two polygons of same number of sides, they are similar if their corresponding angles are equal. What about the second one? If their corresponding sides are proportional. Next, second way, give two different examples of pair of similar figures. Second one, write down, everyone. I'll come and check. Similar figures. Done, right? Second one. For similar figures, you can write equilateral triangles. Then circles. Okay. What about the third one? State whether the following quadrilaterals are similar or not. Only one they are given. No? They are similar or not? No. Why they are not similar? Angles are not equal yet. Tell me third one whether it's similar or not. Why it is not similar? Angles are not equal, so it is not similar. Third one, it is not. It is not similar. It is not similar. Why it is not similar? Because angles are not equal. 2 days I need, afterwards I'll give. Corresponding angles are not equal. Monday I will give that. Okay. Corresponding angles are not equal, so it is not similar. Okay. Next Saturday. Not this one. Next one. This is done, everyone. This is done. Next one. So similarity of the triangles. Similarity of the triangles also same criteria. One is corresponding angles are equal. Wherever it is similar, the what is the criterion? They should have the same number of sides. If they are of the same number of sides, triangles will be always the same thing. The same number of sides will be there. After that, corresponding angles should be equal, and the ratio, the corresponding sides ratio should be the same or proportional. Then we say that two triangles are similar. Okay, clear, right? So now we will study about the theorem. Write down about this. Start with the theorem. Theorem, write down this theorem 6.1. BPT theorem. If a, this is important theorem, many times they will ask in the exam. There will be 4 set of papers. Most of the time, in at least in one set it will be there. 1 or 2 sets it will be there. BPT theorem. Basic proportionality. Okay. If a line is drawn, parallel to one side of triangle, to intersect the other two sides, in distinct points, the other two sides, the other two sides are divided in the same ratio. So if a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay, this is the given thing. Write down. First, what is given? So, what is given in this?
Parallels.
So, ABC is a triangle in which, write down this, in which a line parallel to side BC intersects other two sides AB and AC at D and E respectively. So to prove that AD by BD is equal to AE by EC. In a triangle ABC, there is one triangle ABC. So now DE is parallel to BC. DE we have drawn parallel to BC. Okay, so this line will intersect AB at point D. and AC at point E. Now we have to prove that since the DE is parallel to BC, we have to prove that AD by BD is equal to AE by CE. That means if these two lines are parallel, the line drawn parallel to one side, okay, that line will divide the other two sides in the same proportion that we are trying to prove. Again, I repeat. See, when we draw DE line parallel to BC, that is one side of the triangle, that parallel line will divide the other two sides in proportion that we are trying to prove. So, we are trying to prove AD by BD is equal to AE by CE. Clear? This much you all have. Now, the construction means we will join BE line and the CD line. We are joining BE and the CD line. Then we will draw a perpendicular from E. We are drawing a perpendicular from E. This we call it as EN. EN is a perpendicular drawn to AB. See, AB line and this EN line are perpendicular. This is angle is 90 degree. Then from the point D. Yeah, they will ask. That's why I'm doing. No. We have not told A, D and E are midpoint. No. It can be anything. D and E are not midpoints only. I'm not told it's midpoint. You can't assume because it is generalized. Okay, now from D I am drawing a perpendicular to AC. So this is 90 degree. Okay, this we call it as M. So what is the construction part we have done? We have joined BE and CE, and from D we have drawn a perpendicular to this line AC. That DM is a perpendicular. Now from E we have drawn a perpendicular to AB. Okay, this is the construction part we have done. So construction part, what we have drawn, join. Construction means other than what is given, we are trying to put some extra lines that we call it as the construction part. So join BE and CD. Okay, next draw DM perpendicular to AC and EN perpendicular to AB. Okay, so these things we have done. Now we will try to find the area. Write down this area of ADE. Okay, AD is what? It's a triangle. ADE. It is a triangle. So area of the triangle, how you will take? Half into base into height. Half into base into height. And when you take the base, see for it, how you will take the height? Height means the altitude. That is a perpendicular drawn to the base. That we call it as an altitude. Okay, again I repeat, area of the triangle means half into base into height. Okay, so height means what? It is a perpendicular drawn to the base. That is the altitude or height what we consider. Now, area of the triangle here. Okay, area of the triangle. I'm taking half into, see, if I take AD is the base, AD is the base. So in this triangle from E, draw an altitude that is 90 degree line perpendicular to AB. So EN will be its height. AD is the base. So perpendicular to that base will be the height which you have to consider. So area of ADE is half into base I have taken AD and altitude for that will be EN. Okay. Next, this I'll take it as equation 1. Second, area of BDE. Area of BDE. So that is equal to BDE. This is the thing. Area of this. That is equal to BD into EN. So BDE, listen here. So BDE is the triangle. Okay. So BD is the triangle. Listen here. BD is the triangle. BD is the base. For this, from here, what is the altitude? This is altitude. It can be outside also. You can take just the altitude, perpendicular distance between the other point and the base. Okay. So this is Lakshit. Don't talk. See, when I'm teaching, I'm doing interestingly something you should understand. When I'm teaching, don't talk. I don't like that. Okay. Everyone I'm telling. See here, BD is the base. And that is the base. For the base, perpendicular you have to draw from the other point. So from here, EN is a perpendicular. Even it is outside, that is a perpendicular. That is a perpendicular distance we are considering. So half into, so BD into EN. Okay, so this is the area of BD. What we are trying to consider. Why we are trying to do is, I want AD by BD. So if I divide this, I will get AD by BD. Okay, I want to prove AD by BD is equal to AE by EC. So for that, if I divide here, I will get AD by BD. So that I am trying to get. So one triangle I took ADE, another triangle BDE I took. What we will get? AD by BD will get this side. That's why we are trying to do that. Next, area of ADE. If you take by the other side, what you will get? Half into AE into DM. That means in this, if I take AE is the base, AE is the base, then DM will be the altitude. This is a D. From this point, another point, I'm drawing the 90 degrees. So DM is the altitude. So AE by DM. Okay. I got. Then area of DEC. I'll take area of DEC. That is half into DB as the base. DB. Okay, into EM. Okay. DB if I take, what I'll get? EN. EN as a base. Area of DEC. Wait. DEC. No, it is not DB here. Okay. EC is the base. Then DM is the altitude. See, DEC. EC is the base. Okay. So from D, what is altitude? I have to draw. This is DM is the altitude. So half into EC into DM. This is equation 3. This is equation 4. Understood now? First I took for area of triangle ADE, half into base into height. Area of triangle BDE, half into BD into EN outside, you will get the altitude. Then area of triangle ADE, other way. Now I will take AE is the base. Then DM is the altitude. Similarly, area of DEC. Okay, EC I have taken as the base. Then DM will be the altitude. Dividing equation 1 by 2 and equation 3 by 4. So what I will get now? Area of ADE by area of BDE. So that is equal to area of ADE, what I have taken? Half into base as AD, altitude as EN. Here, half into base as BD, altitude will be EN. Okay. So here, if I, sorry. So area of ADE by area of BDE. Now this is equal to, I will get AD by BD. Okay. Next, 3 by 4. What we have? Area of ADE Okay, by area of DEC. ADE, other way we have taken, base we have taken as AE. Base we have taken as AE, then altitude was DM. Here half into base we have taken EC, then altitude will be DM. So we got AE by EC. Okay. Now we have area of ADE, ADE both are same. What about area of BDE and DEC? Area of BDE is equal to area of DEC. Can you tell why they are equal? Vihan, why they are equal? It's not superior. Both are triangle ones.
Both are inside.
Area of BDE. Okay. This BDE and DEC. Okay. BDE. Another one, DEC. See, I can consider DE as the base for both, correct? These two triangles area is equal. Why means both have the same base DE and DE. And they are both are between the same two parallel lines. Whenever the two triangles have the same base and they are within the same two parallel lines, then the two triangles area between. Somewhere you would have studied earlier. You would have studied. But not in this class, earlier class. It was like, okay. So listen here, DE and DE, they have the same base and they are between the two parallel lines DE and BC only, no? So when the two triangles have the same base and they are between the same two parallel lines, then the two triangles will have same area. Okay, so by that condition, these two areas are equal. The reason you can write, don't write these things, you can just write the reason. The triangles, write down this, the triangles having same base and are in this and are between same parallel lines and are between same parallel lines have same area. Okay, you can write here have same area. I've written here. The triangles having same base and are between same parallel lines have same area. Okay, that is the reason these two are equal. So now area of these two are also equal. That means what? LHS are equal. So if the LHS are equal, then RHS will be also equal. Okay, you can write this as equation 5 and 6. From 5 and 6, AD by BD is equal to AE by EC. Now, write down from 5 and 6. 5 and 6. AD by BD is equal to AE by EC. Converse also, yeah, it is there. Next class, tomorrow we'll continue. I think. BPT only important. Many times I skip converse. Don't skip anything in CBSE. Let it be there. No, we will do it. 10th. Still time is there. No, Aram se will finish. Don't worry. It's not at all difficult. Whole the chapter is there. We will finish. Don't worry. Okay, this much understood now. So tomorrow we will continue with that. Okay.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.